Hi guys and welcome back. So all of you have been chomping at the bit for a challenge question. So what Heather is going to do is that she's going to pose one of her questions that she was going to go through as a challenge question, and then we'll be working through it at the end of the show. See Kashifa, Anisa, Simpiwe, Musa, who says it's too easy. I think it is time for a challenge indeedy. So Heather, take it away.
Okay. All right, so guys, this is a question that came out of one of our exemplar papers. So basically it is as follows, and what Indiana's going to do is she's going to do a screen grab of it, very technical. So once I've gone through it very quickly, she's going to post it, and then you can get working on this, and I'll go back to another question. Okay, so it's talking about a Great Pyramid of Giza. Actually, it exists, also known as the Pyramid of Khufu, was built in 2600 BC, and it's one of the remaining wonders of the world. When it was first built, its height scaled to an amazing 146 meters, and the slope angle of the pyramid is 51.9 degrees. So you've got a picture of the pyramid, okay? And the challenge question is to calculate the slant height PQ of the pyramid. So you've got your picture. Just remember that PQ, that's the one that you're finding there. Okay, that's called the slant height, and they want you to find out the slant height PQ of the pyramid. Got it?
And it is posted.
Perfect. Okay, so let's go back to where we were, going into some 3D trig. Okay, so I know that some of you are really busy with the challenge question, but I find that 3D trig seems to boggle the mind for some people. So I'm going to go through quite carefully what is different with 3D and also getting the kind of information onto the picture. All right, you've been given CD is a vertical mask. So sometimes they tell you about a mast or a lamp post or a netball post or a rugby post or something, but they tell you it's vertical, and so that means that even if they don't draw it in for you, that you have a 90 degree, okay? The points B, C, and E are in the same horizontal plane. All right, so this here is your ground level that's all dotted, that's going along the ground, okay? Then it says that B to D and E to D are cables. So this is a wire, okay? Coming from the top of the mast, there's wire coming down to pegs in the ground. And they're telling us that from D to E, it's 28.1 meters. And from B to C, it's 20.7 meters. All right, and the angle of elevation of D from B is 43.6. Now, sometimes they put this stuff into the picture for you, and other times they actually want you to put it in yourself. Now, this is important. It's the angle of elevation of D from B. So now I always envisage that I've got somebody lying on the ground, okay, and he is at B, and he's looking up to D. So the elevation from B up to D is 43.6. So this here is 43.6 degrees. Okay. Then they tell me that C to B to E is 63. So this one here is 63 degrees. And lastly, B to D to E is 35.7 degrees. Okay. Now, guys, you have to remember that this is 3D. So this dotted piece is definitely the ground, all right? This piece here, the 43.6, is actually an angle measured through the air, and so you cannot think of this 43.6 and the 63 being one angle, because the one is on the ground and the other one is up into the air. That's what your angle of elevation means. Okay, so you've got the picture. Let's get going with the question. The first question is calculate the length of BD. Okay, BD. Now I want you to be aware that BD is actually in a number of triangles. Can you see that it's in this triangle BDE? It's also in the triangle BDC. Now, my hint to you is that you always like to try and start in your right angle triangle first, Okay? And if you have a look at your right angle triangle, you've got BDC. So I'm just going to draw it here. All right? There is the right angle. You know that this one here is 43,6. And you know that this length here is 20,7. And they want you to find BD. So can you see that you've got enough information to either use your basic ratios or your sine rule to go ahead and find that length? Right, so let's go and do that. Right, coming down to the bottom here, we're going to actually tell them which triangle we're working in. Just to be sure, we're working in triangle BDC, okay? So we tell them, in triangle BDC, all right? Remember that we had this angle as being 42,6, and we had this length as being 20,7, and we wanted to find BD. All right? So if we have a look at this 42,6, you have to be mindful all the time that this 42,6, if I were to take it, this would be my opposite. All right? This would be my adjacent, all right? And this would be my hypotenuse. So they're wanting me to find BD. Can you see you've got your adjacent and you've got your hypotenuse, and so clearly we are going to be working with, again, like in the last question, just freakishly, the same thing happened. We're working with the adjacent over the hypotenuse, and we know that that's going to be the cos of my known angle, 42,6 degrees. Okay? So my adjacent is 20,7. My hypotenuse is BD, and that is equal to the cos of 42,6 degrees. No problem. This time I've got to get BD, which means that I'm going to multiply up, guys, both sides by the BD. So that means I'm going to land up with BD up on my right-hand side, and I'm going to divide by the cos of 42,6. Okay, now that means that I just have to pop that into my calculator. So let's go in and have a look at that, if we can just get there. We're going to take 20,7, and we are going to divide it by the cos of 42.6. All right? And that tells me that my side is 28,12. Okay? So BD is 28,12. Now, often, guys, the candidates say, how should I leave the answer? Well, can you see that the original question was calculated to 1 decimal place? And if they haven't said anything, then take that as your guide. And so I'm actually just going to use it as BD is equal to 28,1. But of course, the instructions might have said at the beginning to 2 decimal places, and you would follow that. All right, next question. Okay, it says, show that the length of BE rounds to 17,4 meters. Right, so let's look at our picture again, and we want BE, and we need that to be 17,4. Okay? So let's have a look. I am just a little bit worried because I'm looking at this, Indiana.
Yes.
That's a 43,6. And when I wrote it down here, I wrote it as a 42,6. And that's going to mess things up a little bit, okay?
But it shows you that you should always check.
Always check.
So
But
even now, you're learning from Heather's mistakes.
Okay, so I'm just going to quickly go back and work it out with a 43,6 instead. Otherwise, we are going to land up with trouble, okay? So let's just take it again. I need to just go back to 20.7 and divide it by the cos of 43.6. All right. And it's 28.6 rather than 28.1. All right. Silly chop. All right, so it's
So it
28.
shows you how easy it actually
No,
is
it's
to make a
just-
mistake and
Okay,
how you just got to keep your wits about you.
28.6. So this is 28.6. Okay. All right. So now that we've rectified that, let's go back to the question. Show that the length of BE rounds to 17.4. Now, again, guys, I don't want to sound like a broken record or your mother, but it's show that. Do not use the 17.4 and try and work backwards. Just know that that is there as a checking facility, okay? So we want to go and find the length of BE. So that is this guy here, okay? So let's make sure that we know that that's the one that we're working out. Now, guys, you have to make sure that when you have worked out the first part of the question, which we got BD to be 28.6, fill that into your picture, all right? Make sure that you put it in because now that is useful for you to use. And remember that even if you've got it wrong, makes no difference because as you go forward, you would get continued accuracy marks when we mark, okay? So all is not lost. Even if I had have used my wrong answer, I would have still got method marks, okay? Right, so let's have a look. We want to try and get BE, all right? Now, how am I going to get BE? Focus on the triangle that BE is in. And yes, it's in that triangle BDE, and it is also in the floor triangle BCE. Now, what do you think we're actually going to work with here? Well, you need to work with the triangle that you've got the most information in. Now, if I look at BDE, I've got that side, I've just found it. I've got this side, they gave it to me, and I've got that angle right from the start. So can you see I've got that setup that I actually need cos rule for? I've got two sides and the angle between them. And that's exactly how I'm going to find BE. Right, so let's set that up. Said we're going to use the cos rule, and so we're going to be working in the triangle, and the name of the triangle was BDE, and we're literally going to set up the cos rule. So BE squared is, right, say it with me, let's look at it. BE squared is going to be BD squared and ED squared. So we've got to get our right letters, okay? So it's going to be BD squared and ED squared minus twice the product of these two sides, BD times ED, then cos of the angle between them, and that angle was 35.7 degrees. Right, and now guys, it's really just calculator work once we have substituted all these values in. So my BD is 28.6, which I'm a square. My ED is going to be 28.1, which I'm a square. And I'm going to take away 28.6, 28.1, cos the 35.7 degrees. And guys, I'm not going to bore you with the calculator work because I know that you can all use your calculators. You just punch that into your calculator and you are going to land up with BE squared coming to something that looks like that. Right? But of course, we are going to square root it, and when we square root successfully, we will get 17.4, which was our guide. That's exactly what they said. Right, let's recap. The first question used the right angle triangle. The second question used cos rule. All right, now let's see what the third question says. Calculate the area of BEC. So BEC. So now, guys, we are looking at this area down here. Okay? Now remember, follow my rule. Once you have just worked out a question, they told us that BE rounds to 17,4. So now we know this. All right, can you see how easy this is going to be? Because now we are wanting to work out the area of this floor triangle. We've got that that's 20,7. We've got that that's 17,4. And we've got that that is 63. So literally, it's just a plug and play. So we're going to get our area is equal to half the product of the two sides. All right, multiplied by the sine of the included angle. All right, and so we are literally going to get a half times the product of our one side times the product of our other side. Okay, that went a bit wayward. Okay, so let's just go back. It's a half. And we've got 20,7. Doesn't want to behave. 20,7 and 17,4. And sine, and of course if we just recall that our angle between them in the picture was this guy here on the floor, 63. And once we've popped that in, we're going to get it onto our calculator. And we are going to get 160,4 square meters. Okay, Indiana, have we got anybody coming in with our challenge question, or shall I go on to the next question?
We do. We've
cool.
actually got a few comments, so let's get right to it.
Okay.
Let's hold on. I've got the producer in my ear. You know James. One day mindset is you will see who the
boss is actually.
Who the boss actually is. And Boss Man says we must take a break. So that's exactly what we're going to do, but that's a fantastic opportunity for you guys to get in questions onto the page if you aren't understanding. Also to quickly do the challenge question, and we will be going over it after the break. See you now.